All right. Yeah, I really enjoy these Engage events because it's, as you'll experience over the next couple of days, by the end of tomorrow night, we'll all know each other, we'll have heard all the horror stories, the security issues, and everything else, and also understand more about each other's plans and what we're trying to achieve. And I always, as Phil said, I've been to a few of these. I was at the Smart Cities event they put on a couple of weeks ago. Actually, great event. A lot going on in smart cities right now, as I'm sure you can imagine. And I learned so much by attending that event. So I'm here primarily to learn, but also to share some information. Obviously, we're here to talk about event-driven real-time applications and how that can be a real help. That approach can be a real help to driving digital transformation initiatives. You'll probably be able to tell from my accent that I am a Canadian, but in case you need proof, there you go. I am an actual bona fide Canadian. And I showed that at the Smart Cities Summit 2 weeks ago in the US, and the reaction was a little bit puzzled, like, what is this guy doing here? So, but anyway, we're in good company. VANTIQ is headquartered in Silicon Valley, but I'm very determined to bring the knowledge and the solution that VANTIQ has up to the Canadian market. So let's dive in. This is actually sort of a takeoff from where we were yesterday. I thought Tony, Lars, they gave great presentation talking about digital transformation. The panel was great. And what we're going to do is sort of start where they left off and then quickly dive down 2 or 3 levels deeper into how you actually would do it. So we know that a lot of technology, there we go. A lot of technology is hitting us and hitting you at the same time, which is causing a lot of changing business models. Right now, customers are focused on outcomes, and increasingly they're renting those outcomes. They're not buying products. A friend of mine the other day told me that his furnace went out, and he had a choice. He could spend 15 grand to buy a new furnace, or he could basically rent furnace heating as a service. And I guess that's pretty common in Ontario. I had no idea. I've never heard of such a thing before. But it just, again, shows how the world is moving toward anything as a service, buying outcomes, not buying products or things. We know the virtual world is supplementing the physical world increasingly. It's quite incredible. It's, obviously virtual reality is becoming very big in gaming these days, but augmented reality is really starting to hit the world of business. I was at a field service event a couple of months ago. Brett was with me at that event, and half the solution vendors at that event, there's probably 30 vendors, were doing some augmented reality system. Goggles, heads-up display, eyepieces, associated software. So it's coming. It's absolutely coming, probably quicker than we even think. And then probably in my mind, the biggest factor that's driving this transformation is this push toward becoming a real-time business. Our model, in fact, literally our operating model in IT used to be about batch, right? About storing things up, putting them into a database, and then taking action later. But if you think about most business models that are driving change in the market, and not just change, but actually driving disruption, look at what Uber has done to the taxi industry. They fundamentally rethought the taxi industry by turning it into a real-time business. They know in real time what the location and status is of every driver, of every passenger, of every possible passenger, so they can orchestrate a complex series of interactions that fundamentally blew the taxi industry away. And this kind of real-time driven transformation is in the process of happening in virtually every industry these days, a fundamental driver of digital transformation. And I have to say, when I talk about this and I talk about digital transformation, I often hear, well, but what do we do? Like what projects should I undertake? And I'm really actually excited to have worked with IDC closely over the last 20 years. Actually, Tony and I worked together a long time ago when I was running strategy at Corel in Ottawa. And IDC is one of the only, I believe they're the only analyst firm that has a practice focused on digital transformation. And I'm actually a former Gartner analyst myself, okay? So I can talk about IDC and know how the sausage is made from the other side of the step. But IDC has done something incredible here. They've created a database of digital transformation use cases with actually over 770 different use cases across industries, across functional areas. And really speak to your IDC rep about getting access to some of the relevant information in these use cases. But the thing that I love about these use cases and why VANTIQ finds them so helpful when we talk to customers is about half of those use cases, and I've been through every one of them, about half of these use cases are fundamentally about taking an operational processor system and speeding it up or turning it into a real-time system, instead of a system where you take an action later after you've stored up a list of things to do. So fundamentally, this again reinforced for me how digital transformation and the concept of doing things in real time are so closely connected to each other. And so the challenge, of course, is this is hard. We're dealing with increasing levels of complexity. We have to be more and more agile. We talked about that yesterday. The speed of business is increasing, and we've got everything everywhere, right? All this technology we've built and is increasingly coming at us, IoT, AI, AR, blockchain we talked about yesterday, disrupting the insurance industry. It's all coming, and a lot of it is here already. Human-machine collaboration is also really critical. So fundamentally, most of our businesses are still about people. And our job is to make our people, our employees, more efficient and effective. And so, this notion of artificially intelligent, robots displacing people, who knows what the long-term future will hold. But for now, it's about making people more efficient and effective as they work together with increasingly capable either physical machines or software-driven machines. So human-machine collaboration is something we're thinking about a lot these days. And finally, the decades of legacy applications that you guys have built for your organizations. And somehow, you have to connect all this together so that you can sense what's going in and around your business, analyze it, and then take an action in real time. And a lot of solutions these days actually stop at real-time analytics. So it's actually fairly common now to see dancing charts showing what's happening in your business, maybe data coming in from IoT devices. That's pretty cool to see the real-time status of things. But the power really comes, the part of transform your business really comes when you can take actions in real time as that data is flowing in. Let me give you a few examples. Again, our friends at IDC say, fundamentally, digital transformation is at an inflection point. The technology is here, the capability is here, but the complexity is high. So how do we do it? Well, actually, probably don't do it this way, right? This is building yet another 3-tier request response app where you take a bunch of data, put in a database, which then became a data warehouse and then a data lake, because there's more and more data. Then you have to you query the data, produce a report, and then somebody takes an action later, or a machine takes an action later. That works for certain types of applications. It's well suited for those. But if you're actually trying to build real-time applications to drive some operational element of your business, your smart manufacturing line, your global supply chain in real time, this kind of architecture is not suited actually to real-time applications. So what is? Well, you've all heard, I'm sure, of this notion of event-driven applications, which is becoming, it's actually a couple of decades old, but with the technology that we have now, it's becoming very popular and common as a core architectural component of the new generation of applications. And the fundamental notion here is you have data flowing in and around your business from IoT devices and sensors is very common these days, but also other business systems. Your ERP system is putting off all kinds of data about the status of events, POs, you name it, your employees working on their mobile devices. And all this data are about the events that are happening in and around your business, the status of things, the location of people, the position of machines. So at the core, you're doing what's called complex event processing. You're processing all of that data as it flows in real time. And of course, you have to have some context, right? You have to know, is the state of this system good or bad? If the machine is at 100 degrees, is that a good thing or a bad thing? If the data is flowing in a particular way, can my machine learning algorithm predict that this car is about to break down so I can make sure I position the CIA vehicle where it needs to be? So you have context in the application. And then finally, as I said, you enable the actions to be taken while the data is still flowing in, right? This is actually not a left to right flow, because taking of the actions is also an event. It's causing the system to change. And so as the actions are taking, you're continuing to process the data and orchestrate the system in real time. My friends at Gartner have been doing a lot of writing about event-driven architectures lately, and fundamentally, again, like the folks at IDC, believe that if you truly want to transform your business, you do need to think about a different core architecture. So let me take it down one more level. Here's a pretty common example of an event-driven application. So this notion here is, this is a field service example. So suppose you've got 10,000 air conditioners spread across China. The average air conditioner has 120 sensors on it today, putting off about a gigabyte of data a day. These are commercial HVAC units, so a tremendous amount of data. If you're trying to build a real-time field service application that enables you to take action in real time to proactively repair these air conditioners, you can't have all that data flowing into the cloud. It's just not going to work, latency and bandwidth issues and everything else. So increasingly, these kind of applications are doing edge processing. You're doing the initial processing of the data on the edge in an edge gateway or a local PC, maybe at the building level or at the neighborhood level. And that's possible because, of course, the vast majority of the data coming off that air conditioner could be thrown away. It doesn't mean anything. You don't have to take an action. It's only when you detect that there is a problem or there's going to be a problem, that's when you communicate with the master application, which could be running on-prem in your data center, could be running in the cloud, in a private cloud. It doesn't really matter. Anything is possible. At that point, in this example, you add in some more external context. So in the case of the air conditioners in China, they've got a database of thousands of local repair technicians who aren't employees of the company, but they know through a mobile application what the real-time location of these contractors are. They can poll the ones that are closest to the air conditioner in question. Of course, make sure they have the appropriate training, they're the right level of repair technician, and then bring that person to the air conditioner, again, in real time as the AC unit is continuing to put data off. Now, what happens? The piece of paper that was blocking the vent blows away, air conditioner cools back down again, and the job can be stopped in real time. That's fundamentally a very different experience than most field service that's happening today. But this can be enabled by the kind of data, IoT devices, and real-time processing that is now being done. So there are many different examples of real-time business operations, and again, I'd actually refer back to the IDC Digital Transformation Database, because I think all of these are fundamentally contained in there. But if you think about how your business runs today, how your supply chain runs, both getting stuff into your operation and shipping products or services out in real time, if you think about how you interact with your customers and orchestrating those interactions in real time, any kind of field service is an obvious use case for these kind of applications. Hospitals are increasingly becoming real time. Actually, at the last Engage Canada event, spoke to a couple of hospital operations folks who are doing some really interesting real-time applications, orchestrating the readouts on patients and the status of a patient with the actual physical location of doctors, elevators, the position of beds, all orchestrated in real time to maximize the very fast outcomes for those patients. Smart cities we'll actually talk a little bit about later with an example and a use case. And not all of these are IoT related. Financial services is an area where we're seeing a lot of these applications being built, where again, over the decades, these companies have built many fairly siloed enterprise applications. And they're looking for, you might even call it an enterprise nervous system to orchestrate the interactions between these systems along with the people that are running them. So a lot of different use cases for real time. applications. And so to do this, obviously at the core, you need to be using a platform that does complex event processing that can handle these real-time event applications we're talking about. And there's some elements of these that are important. So first of all, yesterday we talked about mission critical. Every one of these leaves on the clover leaf actually could probably be an hour-long discussion. So we talked about security a few minutes ago. Obviously, security can't be an afterthought. It has to be architected into your application from the beginning. That's very important. As important is having web scalability, so-called, right? Because many of these applications start with a relatively low volume of data flowing in and around them, but eventually it increases, you expand the scope of the application, and you need a platform or a system that is able to scale as your application scales. The other one, which actually isn't touched on here, is about being dynamic. So if you're running your real-time supply chain across Canada, or if you're doing your airport operations at Toronto International Airport, you can't take that application down for 2 hours while you push out an update, right, to the application. Maybe it's running across numerous edge nodes. The application is to be always on, always running, and you have to be able to update it dynamically as it's running. That's very important. Distribution. So we talked a little bit about edge computing in the use case a minute ago. I would say that right now, the edge is still in the science fair phase. I was actually speaking at the Fog World Summit in Silicon Valley a couple of weeks ago, and it was an interesting crowd. You could tell they were all sort of scientists, chief architect types and folks that are on the quite a ways away from the business, all doing very interesting projects. And right now, I think the latest data I saw from Gartner said that only 1% of enterprises have any kind of an edge computing project live right now. Okay? They're predicting by 2020 that'll be 40% of enterprises will be doing a live edge computing project. And 2020 is only 2 years away. So this is happening very quickly. Again, the volumes of data that we're having to process are becoming so large, they have to be processed on the edge. They can't be processed at the core. And many other reasons why distributed computing is becoming really critical. Human-machine collaboration, we talked earlier about briefly. So who can tell me what this is a picture of? Any guesses? Tesla. This is the Tesla Model 3 assembly line. Where are all the robots, and where's Elon Musk's vision of turning out the lights and having just Model 3s spit out the other end, right? Well, he tried that, and we know what happened, right? It fundamentally failed. For him to achieve what he needed to achieve, he needs people and machines working together collaboratively, right? He needs to leverage the wisdom, experience, knowledge, flexibility of people, and that's the only way he was able to get those Model 3s out and hit the numbers actually he announced recently. So one great example of people and literal, in this case it's literal machines, but increasingly when we talk about human-machine collaboration, we're talking about intelligent systems. Machine learning algorithms, those kind of things. I shy away from using the term artificial intelligence because it's like the robots are coming to get us. It's really more about, I think machine learning, deep learning, neural networks, those are more interesting, relevant ways of thinking about the new technologies that are coming to increasingly help us. By the way, a year ago when I began doing more research into human-machine collaboration, I set up a Google search term for that, and I'd get maybe 1 hit a week. I get about 5 a day now for human-machine collaboration. It used to be about HMI, human-machine interface, and building simple interfaces for people to use or buttons to press. But now it's literally about how, again, driven a lot by machine learning, how people and systems are literally collaborating together in real time. Okay, so all that is good, but the final part, or the key to bringing it all together is about speed, about agility, about productivity, right? Because people have been building, mission-critical, scaled, real-time applications for decades. It's not actually a new concept. airport control systems and you name it. But the challenge is it's very hard, right? And maybe some of you have been involved in those projects over the years. Why is it hard? Well, you're dealing with, events flowing in asynchronously. This isn't your standard business process management flow where A, then B, then C, then D, right? You might get A starting the system, B never happens, you get two Cs. What do you do without a B? You have to think through all the possibilities. And this approach to doing this is called reactive programming. I'm sure some of you are aware of the concepts. It's very complex. So you got these asynchronous events flowing in, streaming in real time at increasing rates of speed, increasing volume. And again, many of the use cases are involving edge computing these days for exactly those reasons. And then finally, you got people. And whenever you put a person in a system, as you know, because you've been building software systems for years, everything gets more complicated, right? You can attempt to control a machine or a software system, but people are impossible to control. Everything gets a lot harder. And the interesting thing is, as machine learning and some of these intelligent algorithms are starting to become more prominent, as we know, those are also fundamentally black boxes, just like people are. You put in some inputs, you get an output out of the system, but you don't really know why. Why did the machine make that decision? So intelligent machines are starting to become as unpredictable as people are, interestingly. So it becomes again, more and more complex to create these applications. So we're lucky though, because the concepts of low-code, no-code, high-productivity application development that have been around for about 10 to 15 years are now finally starting to be applied to this notion of real-time event-driven applications. So we've been doing, graphical, easy, quick, agile application development for three-tier database-centric apps for quite a while now, and some of the systems and solutions out there. Finally, these are being applied to this notion of real-time event-driven apps just in the last couple of years. And this notion of competitive stamina, I think, is really critical because it's not only about speed, it's about agility. The notion of sustained competitive advantage is virtually gone, right? It's about what are you doing now, and then now, and then now to keep your business ahead. There's no such thing as building an advantage that's going to keep you in the lead for years to come. So you need to be continually changing, modifying, re-architecting, adding capability and functionality, and changing the core model of what you're building. And so you frankly have to use these kind of methodologies to make that happen, because even if you have the money to hire large groups of developers and build massive enterprise systems like the old style of event-driven applications, even if you have the money, you no longer have the time. By the time you build that, by the time your year-long project is done, the business has already moved on 3 times, right? So that competitive stamina is fundamentally about agility in my mind. So there's the current way of building these applications, and then there's this again, so-called low-code, no-code, really not a new concept, but applying it to real-time event-driven apps is actually fairly new, and the difference is dramatic. Let me close by talking about a smart city use case, a real-world use case, and for those that are actually in the working group sessions later, you're going to see one of these applications running. But a good example of how you might, start with one real-time application, but then once you get the ball rolling, very quickly slide and expand into others. So in this case, we've got the Public Works Department in a city, and they need to build or operate a real-time field service application, sort of similar to the one I described earlier. They've got all these buildings, equipment that belong to the city, and they have to keep them up to speed and working properly. And so to do that, they built an application that takes a bunch of event data sources in real time. These are just a few examples. And based on that, they built an application that enables that real-time field service, and they put out a new kind of event called a field service action in progress, so that other city departments can see what is actually happening in the field service organization. around the time Public Works got this done, the city police said, well, we want to get into this. We've got to provide facility security for city buildings, parking lots, both inside and outside the building. And you can see they're also making use of this parking meter status event stream. Again, these aren't all the events they used, but these are just some examples of the events they used. So they're sharing that event stream with Public Works, and then they're taking in a bunch of other event streams into their real-time application. And they're actually putting out, in this case, 3 new event streams. The status of unauthorized vehicles in parking lots, unauthorized people in buildings, and then a record of police actions in progress. Now, after this gets built out, here's where it starts to accelerate and become really agile, because when the transportation department wants to get into the game to build a real-time traffic routing and rerouting application, well, they can just go to the city's event catalog, this catalog of these events that they've either have coming in or have some of these applications have created, and they're using these 4 event streams that already exist. They're already there, so it's very easy and quick to build this application, and of course their application puts out a couple of new event streams that could be used by yet another city application and another city application. So this is an example in a city, but you can think about your business or your enterprise, how you could do something similar. You know, start small. Start with an application or a transformation use case, like one of those 800 use cases that IDC has, and get a quick win with a project that takes a few weeks, literally, and then use that to leverage into an adjacent project and the next one, and the next one, and the next one. It actually becomes easier as you do more. One of the fundamental mistakes I think many businesses make when they think about digital transformation is the word seems to imply boiling the ocean, doing everything. And I think for us to be successful, it's actually do the opposite, do one very small thing, and then expand from there. So that's real-time, event-driven applications. That's my case for looking at them. And we'll obviously be happy to talk to you more about them during the one-on-ones. You will see actually something similar to the city police facility use case in real time here in a few minutes when we're done. And now we have a few minutes for questions.
Any questions for Blaine?
Don't be shy.
I got one. Could I have your name again and company, please?
Hi, this is Ian Drumea from BDC. I'm looking at the picture you have there, and obviously it presents a real business case. I'm wondering, I've seen this picture before in the blockchain presentation. So how do you see these 2 technologies compare, or one evolving into another?
The question is around blockchain and how does that relate to real-time applications. It's interesting because to some degree blockchain is you could think of it as almost the opposite of a real-time application. You're creating a permanent distributed ledger, right, of all the actions, activities, contracts, whatever the use case is. And right now, in fact, blockchain technology is actually relatively slow and hasn't lent itself to these kind of applications. But fundamentally, in fact, this notion of real-time applications and event-driven apps are incorporating this notion of an event ledger right now. So there are some types of events, for example, the police actions in progress, you might actually need a permanent ledger of these events stored in a blockchain application so that, let's say in the US or in Canada, the RCMP can look at all the city police departments and see exactly what's going on, have an immutable, unchangeable ledger of all these activities that take place. So I think absolutely you can build applications that incorporate blockchain as one of the ways of storing and distributing data in the database. But keep in mind that most event-driven application data is ephemeral. Right? You couldn't possibly store all the data flowing through the system in a regular database, let alone put it in a distributed blockchain ledger. That wouldn't make any sense. But some of the events that you create, in fact, maybe some of the blue ones on this chart here, it would make sense to put in a distributed ledger, a regular database, or even a blockchain system, depending on the application. We're still waiting for our first client to have a use case that fundamentally requires blockchain. To be frank, we're still waiting for that to happen. So a lot of folks are thinking about blockchain and looking at the possibilities, but we haven't found too many people actually doing much yet.
Any other questions?
If we don't have a question, can I make an editorial comment really quickly? One final comment to close. So I attend a lot of IT-oriented events like this with CIO events and technologists like yourself. And then I also attend a lot of operations-oriented events like field service events, manufacturing, smart cities, you name it, where it's operations folks, OT folks. And whenever I attend the operations events, I ask the audience, or if I'm sitting at a round table, I say, so what do you think about who's going to build these applications for you? You want to dramatically change how your manufacturing system works, your global supply chain, your field service organization. You want to transform your part of the business. Who's going to build that for you? And they all say to me, well, I know who it's not going to be. It's not going to be IT. And I say, not I. Well, the first time I heard this, I jumped back. Now I'm not surprised anymore, right? But I say, well, who's going to build it if it's not IT? Well, it's going to be our ghost IT department, or it's going to be a systems integrator, or somebody we bring in. Well, why isn't it going to be IT? Oh, well, they're working on SAP implementation number 7, or security, or improving security, or cloud migration, generally moving existing applications and capabilities to the cloud. And if I want to redo my smart manufacturing line, I'm going to get in the queue and wait for the next year and a half before I can get this project done. And I need it done next month, not a year and a half from now. And so I bring this up just as a challenge and editorial comment, I guess, to the group is I fundamentally believe IT organizations need to be on the driving edge of these transformation initiatives. I think you can be, and your line of business partners they're open to the possibility, but they're skeptical. They're skeptical. So get in there, grab them, pick some of these use cases that we talked about earlier, and blow their minds that you can actually drive some really interesting projects for the business. I think that's critical to your mandate and your success. So anyway, look forward to talking to you more throughout the next couple of days.
Thank you, Blaine.